Welcome. One of those models that Ben was talking about, which I've known Ben for, God, how long have I known Ben? Like almost 10 years now, was Llama. So who is excited about Llama? Who uses Llama today? Anyone? Okay, a lot of hands, okay. And who uses a 405B, actually? Kind of curious. Okay, no one uses, okay, no one can afford it. Okay, well, we'll talk about it anyway. So I'm Joe Spisak. I'm with Meta, and just briefly about me before we jump into stuff. So again, I'm product director at Meta. I lead our open source efforts for generative AI, including Llama. I spent a lot of time building PyTorch, almost 5 years in that project. So hopefully folks know about PyTorch. Some folks have used PyTorch. I hate to say it, but it's almost like the forgotten soldier, because everyone just like uses tools and libraries above the framework these days. But it's still alive and well. PyTorch conference is next week. You should go. It's gonna be amazing. We'll have some great talks. I'll be speaking again if you want to hear me speak again. I've also helped build the foundation around PyTorch. I've helped build the AI Alliance, and some of my IBM friends and colleagues are here who work with me on the safety working group. I'm also an angel and an advisor in a number of companies. You can read the list. And I've also spent some time in research, building projects in math and science, including protein folding, AI-guided material discovery. A lot of those actually have turned into startups, which is also pretty cool. So I do some light investing as well. So obviously we're here to talk about AI. This is an AI conference, and LLMs are kind of like the foundation of a lot of that, which is why it gets a lot of folks excited. We've also seen things like text-to-image generation and text-to-video, which is super sexy and cool these days. And we've also, what I think is actually the kind of the coolest part is we're starting to put tools in the hands of developers to build their own agents. And like that's kind of at the open source level, but also we released a service just a couple weeks ago called AI Studio, and you can actually kind of build and customize your own agent, deploy it, and you can kind of have fun with it, give it a personality. So I think we're kind of at the precipice of something really kind of interesting here. And I think a lot of that has started, I've been in the machine learning space now for, I guess, 10, 11 or so years, and I joined the party around the ImageNet era. Does everyone know even what ImageNet is these days? Okay, I see. Some old school folks. So we had this whole streak of like CNNs, these convolutional neural nets, and obviously NLP was big with LSTMs and recurrent nets, and the data on the compute was scaling, but it wasn't scaling, I would say, at the level that we're scaling now, where you have Elon Musk building 100K H100 clusters in 121 days or whatever he's claiming. But the compute is real, and the size of the clusters and the HPC or high performance computing level that we're using to build these models is real, and it's exceeding my wildest dreams, having spent time in the HPC space. And so that's training on things like images, video, speech, text, obviously, PDFs, so documents and archive papers, like anything we can get our hands on as a community, we train on it and start building, kind of intelligence. And so there was this whole ML space where we have now it seems so passé with classic AI, but classic AI, for the record, actually makes a lot of money. Where things like personalization, things like being able to use classifiers like CNNs to remove, for example, images or hateful images or hateful memes in the case of some of the data we've open sourced, but also just the day-to-day of running companies these days is actually a lot of still classical AI. And obviously what's different with generative AI is it's really brought creativity, and it's brought the functions of AI much closer to how a human perceives and plans and just much closer to us, and actually even the abstractions, because ML at the end of the day is an abstraction game, right? There's different levels. We have developers at very low levels, like researchers, but what's changed with generative AI is kind of everyone can kind of touch and feel and really engage with this technology, and that's really been a game changer. And so when I think about the landscape, and this is thanks to my friends at Sequoia and Stephanie and team, I think about this in terms of also layers. And I tend to operate in my career and kind of now, I tend to operate at the kind of platform layer. And today that is LLMs as a service, that's models abstracted as APIs, obviously open source, open weight models available for different abstractions, whether that's models as a service or an API, RESTful API. We've also seen enterprise adoption, I would say, at the fastest pace I've ever seen. It's been pretty incredible how it's been adopted and how quickly companies are testing and building prototypes, and some of them even deploying at scale. And then we've kind of unlocked this new kind of prosumer level where people are willing to pay kind of a subscription fee and stuff to get access to model capabilities or these agent capabilities. And then all the way to the consumer where my company Meta mainly focuses with our family of apps, things like Instagram, WhatsApp, Messenger, and so on. And we're trying to incorporate more and more generative AI to make it a much more immersive experience. And so all of that has kind of culminated in a lot of growth for Llama. So when I'll talk more about the models themselves here in a second, but when we launched Llama 1 last year, we did not kind of expect this level of usage or just excitement. And so a couple weeks ago, we kind of polled a few of our partners and kind of asked them what kind of adoption are you seeing? Are you, how many literally how many millions or trillions of tokens are you seeing? How many downloads are you seeing? And we were blown away. We've seen with Hugging Face, for example, over 350 million downloads. We're just in 3 months earlier this year, we saw a doubling of the token volume, and our cloud providers just selecting a handful like AWS and others, and just the overall usage from January to July 10x'd. And so you can kind of see in this graph it's real. The usage is out there. It's incredible. It's started this big movement, and we're seeing just an explosion. if you go on Hugging Face, like Ben mentioned, derivative models, there's something like over 50,000 public derivatives available of Llama. So this is real, it's happening, and we're super excited. So by the way, with all of my images, I always put the prompt. So if you want to go to meta.ai, you can always put this prompt in, and it'll actually generate for you. And here, of course, an ecosystem of llamas in space is what I prompted. So just digging into what Llama 3.1, so I actually can't believe we shipped these models just 6 weeks ago. It feels like it's been literally a year, but that's true. We did. So if you kind of look at the timeline of where our models came, February 2023, we released Llama 1. Does anyone know the team that actually built Llama 1? Kind of curious. No? Okay, so our friends at Mistral actually were the team. They were one of my teams in FAIR actually that were building AI and theorem proving. They were doing research and kind of tree search and LLMs. At night, they were building LLMs, and that actually is how Llama 1 came to be, which was kind of cool. And then, but that was a research-only model. We released Llama 2. There was a commercially available model in July. And then really this avalanche of releases has started. We released Code Llama and Purple Llama in kind of August through December. This past April, we released Llama 3, and that was a 8 and 70B. Models got incredible adoption. And then most recently, the 8, the 70, and the 405B, and the 405B being the largest and what we consider a frontier class model in open source. And the adoption of that has been pretty amazing. We've also released a number of things around our models. And I'll talk more about this in a couple slides, but we kind of see it's, the core LLM is a key piece, but there's a lot of things that kind of go around the LLM that kind of help you build essentially an agent or much more complex systems. And you can see these are literally the model numbers. They're very marketing-y. But you can see on the right here, we have different guardrails. So we started to release, starting last December, essentially guardrails that allow you to moderate the inputs and outputs of your models and be orchestrated along with the core LLM. We call that Llama Guard. So basically that is like a 10 category taxonomy model that filters the inputs, filters the outputs. And every model that we release and the new capabilities that we release with each model, we will release a Llama Guard or some guardrails. And so, for example, with multilingual in July, when we released that, our guardrails became multilingual themselves, and you can start to filter out those kinds of things as well. And the really cool thing about the models that we release is you can fully customize these. And we've actually spent a lot of time with ML Commons, and we started to help standardize how this actually happens in practice. Llama Guard was chosen by the ML Commons team as a benchmark and as a baseline, along with, of course, the core Llama models. But again, you can kind of customize, and you can add to the taxonomy if you want to add a different harm or remove a harm or for whatever reason. But we've also released things like Prompt Guard for prompt injection attacks or even cyber security evals, which are kind of world-class and kind of the first of their kind in the space. We have a very, very strong cybersecurity team at Meta, and they love to do open source. And so in that release, the one thing we talked about is, is we have these smaller models, these 8B and these 70Bs. How do we actually make them obviously better themselves, but then how do we improve them, and I'll get to that in a second, from the larger teacher model, the 405. So with the 8B and the 70B, these became multilingual, they became longer context, and one of the coolest things that I think is that they became very state-of-the-art in tool use. And so, as we've kind of figured out over the last year or so, agents call functions or tools, and they can become much more immersive and much more complex. They can call search, they can call RAG, they can do a lot of different things that, frankly, the core model just isn't capable of doing. And the really fun part about this 405B, as I mentioned, is it became a teacher. And I think, when you look at Mark's interviews just last month or in July, we saw the 405B as a way to improve smaller models. It becomes this platform, essentially, that we can use to distill, that we can then improve a smaller model, and it generates synthetic data. We can fine-tune it. We can deploy it. We are deploying it in production at scale. We have partners that are deploying it in production at scale. We actually thought it would be too expensive to deploy, but it turns out this community is amazing. And we're seeing even today, this morning, Samba Nova launched a service, a cloud service based on 405B. It's the fastest out there. Grok has a 405B service. Our cloud provider friends at AWS, Google and Microsoft are offering it. So it's the prices and the cost of running these kind of models is actually dropping pretty quickly. But the really cool thing was this model actually allowed us to improve the 8 and 70. We generated data in the form of logits and fine-tuned, and then was able to basically build better models as a result. And actually before I get to that, one of the cool things we did in the license for the 3.1 models is we actually changed the terms. So this is something that you couldn't do with a lot of closed models, is you couldn't actually use the outputs to improve any model. We actually sat down and took a step back at the license, looked at it, and said, that's crazy. Why would we not want people to use the outputs and use this amazing model to go build other models? So we basically made that explicit in the license and removed that restriction. And now we're seeing this kind of explosion of synthetic data generation services and distillation services and startups building around this. And this is what we wanted. We really wanted the innovation to happen. And so when I look at how we actually built this model, so if you ever, by the way, work in a company and you actually build LLMs, it is an experience of a lifetime. There is so much that goes into it. This is a whole fireside chat in itself. It's exhausting. It's you don't even know what you don't know until you've actually gone through the development and shipped a lot of models. But I'll hit the high level for everyone here. So one of the things we took to heart is scale. And you can see with Llama 3.1, and especially the 405B, we pushed on really data scale as well as compute scale. And we kept the architecture pretty simple, actually. It's essentially a transformer autoregressive architecture. It uses GQA, or what's called group query attention, to improve inference time performance. But otherwise, it was a very simple, dense architecture. But we really pushed on scale hard. We pushed on data. We trained it on over 15 trillion tokens. It took us months to train it. We trained it on 16,000 H100 GPUs. That was the largest contiguous cluster we used to train a single model. And obviously, we're building even bigger compute. But keeping all those GPUs up and running without failing was a huge task for our infra team. And the result was pretty cool. So we didn't shy away when we released the 405B just again 6 weeks ago. We compared it against what at the time were the best models, and frankly are kind of still the best models. That's GPT-4, that's GPT-4o or Omni from OpenAI, and then of course the Claude 3.5 Sonnet from Anthropic, which is a fantastic model. And we were really excited about the results. If you look at the kind of academic or standard benchmarks, whether it's on reasoning, whether it's on mathematics, whether that's on coding, long context, tool use, we were actually in a really good place, beating on a lot or beating on some, and really being competitive on a lot. So we were really happy with the results. So this is like basically getting a world-class model just available to you, and you have the weights, and you can fine-tune, you can do anything with it. But I think like what we've learned in the generative AI space is auto evals and kind of academic or kind of MMOU kind of benchmarks are really cool, but they're also getting saturated. And you can actually game these benchmarks. You can kind of train. I mean, I don't want to accuse anyone, but you can definitely train on the test set if you really wanted to. So there is definitely a lot of games being played. And this is why we start to look at other benchmarks. We look at LM-Sys and Chatbot Arena, and how do we actually interact with these models as humans, and that kind of gives us an idea really of how good the model is, how is it formatting the data back to us well, what is the tone of the model. Now, these kind of things are really hard to take into account when you kind of have a standard set of prompts for reasoning and so on. But one thing we do as a community is we also do human evaluation, and this is very expensive. This costs millions of dollars, and it's time intensive and it's labor intensive, and we also compared our models there. And we were quite, we were, I would say, in a pretty good place comparing to, Sonnet as well as 4.0. But this kind of gave us a real indication of, okay, the auto evals are good, but also we feel like humans like them. People like using the models, and people like playing with them and interact with them, which is way more important to us. And so, one of the things, as I mentioned, is like the 405B itself was quite expensive, and it was not easy for developers to onboard. You can't just download, gigs and gigs of data and then be able to deploy that. You don't have the compute to run on your MacBook or even in a standard instance on, say, AWS. The original model actually required distributed inference, which means it actually needed to be sharded across multiple, say, 8 H100 systems in the cloud, which again is like not easy, not cheap, and technically actually quite difficult for most developers. In fact, even some of our most advanced partners couldn't actually do it. But we worked really, really closely with them. We had over 25 partners at launch. You can see every single checkbox here was a night, a weekend. A lot of meetings, a lot of engineers collaborating, working together. Some of these were net new services that just weren't even available prior to this launch, like synthetic data generation or distillation. So it's a pretty incredible community we have. And you can see just some of the logos of who the folks we work with. We work with, obviously, folks who provide platforms, GSIs, silicon partners. We think all the way down to the metal, to the infrastructure, and then all the way through to the platform and even end users. Okay, so that's Llama 3.1, that's Llama. Now I'm gonna just go through a little bit in how you can actually get engaged, how you can interact, how you can actually play with these models, what's available today. So one of the things that we really wanted to push on with the 3.1 release is agentic apps. There's so many agentic frameworks out there, a lot of open source tools. Some of them are really fantastic. But we kept getting the ask of what is the Llama way to do things? Like, give me something that's built for Llama. And so we took that to heart, and we started to really build out these recipes and build out tools and build out APIs. And you can kind of see just a basic agentic app running kind of in the background there. This allows you to call, things like coding, like a code interpreter or a guardrail or those kind of things. And so we started to open source these things. And so you can actually go to our GitHub, the Meta Llama repo, and look under agentic apps. And we have a bunch of apps that you can just basically start with and play with, and even have zero-shot tool use and Wolfram and Brave Search and a bunch of things that are kind of built out. So you can basically copy and paste. The other thing we're doing, so we actually, in good open source form, near and dear to my heart, we actually wrote an RFC, or a request for comment, on an API, put that on GitHub, right around the launch time. We got, I think, close to 30 responses, some of them really, really in-depth responses and suggestions on something we're calling Llama Stack. And Llama Stack is essentially a standard way to interface with Llama models. And that includes everything from how you would do run inference, how you would do something like RAG, or what we call memory in this case, how you would fine tune, kind of all these different capabilities in order basically to give you kind of a standardized tool chain. And so what does that do? On one hand, we have these component makers and these ecosystem projects that want a standard way to interface with LLMs. You can imagine someone like LangChain or Llama. We work closely with both. And then on the other side, we have these platform partners that are also trying to draft off of Llama. And every time we would release new models, they would have to go and reintegrate with all these things, because maybe our prompt format changed, or maybe the way we did tool use and how we emitted JSON or our Python changed. And so they were like, okay, help us here, please. We have so much engineering work every time you guys do a release. So we wanted to start to standardize things. And that's really what Llama Stack is. So it's fully open source. You can see from the GitHub repo here, it's truly in development, but moving incredibly fast. You can start to see some of the pull requests that are coming up from folks like Fireworks and Llama, and there's a few other, I think, since I took the snapshot. But basically, it gives you the standardized way to do inference, safety, memory/RAG, and kind of all the different key components. And the reception to this has been absolutely incredible. And we have all this standardized in our docs and resources. So llama.meta.com, you can go there and you can check it out. It has all of our, you can download the models. We have pointers to partners. They have integrations with LangChain, Llama Index, like kind of every possible library you could possibly think of, how to quantize these models, how to fine tune them, how to validate them. It's kind of all there. And I think the easiest way, which is kind of fun, is you can actually go to Meta AI or meta.ai actually, and it's free, you don't even need to log in. You can actually prompt these models today. You can ask it to generate images. You can actually get them to animate the images. You can play around with the 405B. It's free of charge. Do comparisons. People do that all the time, and they post YouTube videos, and I love to see that because I'm not very creative when it comes to prompts, so I like to see people try and break our models or try and get them to generate interesting things, ask it hard questions, and so on. If you're a Instagram or Messenger user, we have what's called Imagine, which is kind of fun. You just use the kind of hashtag Imagine, and it'll generate something. If you wanted, you can ask it to generate something. You can also ask it to create caricatures of yourself if you do the right things. And then actually, who has played with the Ray-Ban Metas? Cool. So they're really cool. I never thought I actually liked glasses because I'm kind of old enough to remember the Google Glass days. No offense, Google, but like they're really freaking cool. I mean, they're the audio. I listen to podcasts on them. They have the agent is actually quite snappy because they run a lot of things right on the device. There's a whole bunch of work that's happening to make sure that the models run really, really fast, right in that really compact footprint. So I think the best way and the easiest way to play with this is honestly to use meta.ai or the Meta AI agent that's on our family of apps. And that is all. And hopefully you enjoyed that.